Pause the film now to do the question before me. So the sum of the first 48 terms, S48, is given by 24 multiplied by 2a plus 47, n minus 1, d. And in the same way, the sum of the first 36 terms is 18 half of n multiplied by 2a plus 35d. And we know that the sum of the first 48 terms, 24 lots of 2a plus 47d, is equal to 4 times the sum of the first 36 terms. Okay, so I've got an equation there with a's and d's in it. I'm going to multiply out both sets of brackets to give me 48a plus 1128d equals 144a plus 2520d. Rearrange that. Minus 96a on the left equals 1392d. And so a is minus 14.5 times d, dividing both sides by 96. Now we're asked to find the sum of the first 30 terms. And the sum of the first 30 terms is given by the formula S30 is 30 over 2 multiplied by 2a plus 29d. Let's substitute our expression for a into this formula. We're going to have 15 multiplied by 2 times minus 14.5d plus 29d. Let's continue to simplify that. That's 15 times minus 29d plus 29d. Well, that's 15 times 0. So the sum of the first 30 terms is 0. Pause the question now to do the question before me. Right, we need to write an expression for the nth term of this sequence. Now the nth term is going to be n lots of n plus 1, because, for example, the sixth term is 6 times 7, and that's going to then be divided by 2. So there's an expression for the nth term of the sequence. And we're proving algebraically that the sum of any two consecutive terms, so we're going to need to know the generalized form of the next term as well, so the n plus 1th term. Well, if the nth term is n lots of n plus 1, then the n plus 1th term is going to be n plus 1 plus times n plus 2 over 2. So there's an expression for two consecutive terms, the nth term and the n plus 1th term. Now I've got to look at the sum of those consecutive terms. So I'm going to add up my two algebraic expressions. I've got n lots of n plus 1 over 2 plus n plus 1 multiplied by n plus 2 over 2. Let's write that under the common denominator. Let's multiply out that bracket, n squared plus n plus, now I'm multiplying out n plus 1 lots of n plus 2, n squared plus 3n plus 2. I'm going to simplify the top there. I've got 2n squareds plus 4n plus 2, and that's all over 2. So if I halve the top, I'm left with n squared plus 2n plus 1. So there is an expression for the sum of any two consecutive terms. And now I need to prove that that expression is always a square number. Well, if I look at that expression equals n plus 1 squared. So the total of the two consecutive terms of the sequence is always a square number because it can be written as n plus 1 squared, as something squared. Pause the film now to do the question before me. Now we know that the first term of this sequence is minus 6, and we know that the sum of the first 30 terms is 2,865. So an expression for the sum of those 30 terms is n over 2, 15, times twice a plus 29 times d. And we know that that equals 2865. So I'm going to get an equation here which will enable me to find d. I've got minus 180 plus 15 times 29, 435d equals 2865. So add 180 to both sides. 435d is 3045. Divide both sides by 435, and d is 7. So now I know the first term is minus 6, and I know the constant difference is 7. I'm asked to find the ninth term. So that will be the first term plus 8 of the differences. And so the ninth term will be 50. Pause the film now to do the question before me. Now, we know that the 25th term is 44.5. So that tells me that A plus 24 differences is 44.5. Let's come back to that in a moment. We also know that the sum of the first 30 terms is 765, which means that we know that 15 times twice A plus 29 differences equals 765. So that tells us that 30A plus 29 times 15, 435D, equals 765. So now I've got two equations. I've got 30A plus 435D equals 765, and I've got A plus 24D equals 44.5. So if I solve those simultaneously, I'll be able to find values for A and D. Let's multiply the second equation by 30. Gives me 30A plus 720D equals 44.5 times 30, 1,335. And now let's do this equation here, subtract this equation here, because the A's will disappear and I'll be left with 720D minus 435D gives me 285D equals 1,335 minus 765, 570, and hence D is 2. Substitute that value for D into one of your equations, and you'll find that A is minus 3.5. So now I've found A and D, and I'm asked to find the 16th term. So the 16th term will be the first term, minus 3.5, plus 15 of the differences, 15 times 2, which is minus 3.5, plus 30, which is 26.5. Pause the film now to do the question before me. Right, I know how to work out the sum of all the first 100 terms. But we don't want the sum of all the 100 terms. We want to lop off all these ones because we only want the sum of the terms from the 50th to the 100th. So what I'm going to do is I'm going to find the sum of the first 100 terms, and from there I'm going to subtract the sum of the first 49 terms, because then I'll be left just with the total of all the terms from the 50th to the 100th, including the 50th and including the 100th. So the sum of the first 100 terms is going to be 50 multiplied by twice the first term plus 99 times the common difference, which is 7. And from there, I'm going to subtract the sum of the first 49 terms. 49 over 2 multiplied by twice the first term plus 48 of the common difference, which is 7. So if I work that through on my calculator, then this first expression comes to 35,450. That's the sum of the first 100 terms. And the first 49 terms, they total to 8,624. So the sum of all the terms from the 50th to the 100th term inclusive is 26,826. Pause the film now to do the question before me. Right, I'm told that the sixth term, which by the way is the first term plus 5 differences, equals 39. I'm told that the 19th term, which by the way is the first term plus 18 differences, equals 7.8. So I can solve these equations simultaneously. If I do equation 2, subtract equation 1, I find that 13d is equal to minus 31.2. And so dividing both sides by 13, d is equal to minus 12 fifths. Substitute that into either one of the equations, and you will find that a, the first term, is equal to 51. Right, the question asks me to work out the sum of the first 25 terms. So that's going to be half of 25 multiplied by twice a plus 24 of the differences. The difference is negative, so just make sure you work your way through this carefully on your calculator, and you will find that's 12.5 multiplied by 44.4, and so the sum of the first 25 terms is 555.